Article 358 of the National Electrical Code, or NEC, provides guidelines for the proper support of electrical metallic tubing, or EMT. This information is crucial for ensuring the mechanical stability and safety of EMT installations, especially in riser applications for Datacom cabling. For general requirements, it is necessary to securely support the EMT according to the NEC Article 358, use approved supports, clamps, and fittings, and maintain proper spacing between supports to ensure adequate mechanical stability. For vertical support, EMT should be supported every 10 feet, or 3 meters, on vertical runs. Use listed pipe straps, U-bolts, or other approved supports. Securely tighten supports to prevent EMT from moving or sagging. Use additional supports at bends, offsets, and where the EMT changes direction. For horizontal support, EMT should be supported every 4 feet, or 1.2 meters, on horizontal runs. Use listed pipe straps, J-hooks, or other approved supports. Space supports evenly along the run to ensure uniform distribution of weight. Securely tighten supports to prevent EMT from moving or rotating. Use additional supports at T's and elbows to provide extra stability. Regarding unsupported spans, EMT may be installed without support for the following distances: firstly, up to 36 inches, or 914 millimeters, on vertical runs, and secondly, up to 12 inches, or 305 millimeters, on horizontal runs. In areas prone to earthquakes, which are called seismic considerations, provide additional support for EMT to resist lateral forces and use seismic rated supports designed to withstand the specific seismic zone rating. During inspection, the authority having jurisdiction, or OJ, will likely focus on the following aspects: firstly, proper spacing of supports; secondly, use of approved supports and fittings; thirdly, secure tightening of supports; fourthly, prevention of EMT movement or sagging; and fifthly, compliance with NEC Article 358. Here are some additional tips. Firstly, use EMT conduit bodies or junction boxes for connections and pull boxes. Secondly, protect EMT from physical damage by installing it behind walls or in conduit. Thirdly, consider using flexible conduit or sleeves or transitions between EMT and other raceways. And fourthly, label EMT clearly with wire markers or tape. By adhering to these guidelines, Datacom installers can ensure that their 1-inch EMT raceway installations are safe, compliant, and mechanically sound. These guidelines are based on the NEC and industry best practices, providing a framework for proper EMT support in building risers. Let's delve further into the specific requirements and best practices for supporting 1-inch EMT in a building riser for Datacom installations, ensuring compliance with NEC Article 358 and promoting a safe and reliable infrastructure. Focusing on the NEC guidelines, firstly, NEC Article 358 is the primary reference for EMT installations, outlining requirements for support, grounding, and other critical aspects. Familiarize yourself with the latest edition of the NEC to ensure compliance with all applicable regulations. Secondly, use listed and labeled equipment. All fittings and support hardware must be listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, or all. This ensures that the materials meet industry standards for safety and performance. Thirdly, proper grounding and bonding. EMT must be properly grounded and bonded to provide a low impedance path for fault currents. Use grounding bushings and bonding jumpers to ensure continuity throughout the raceway system. Let's now dive into vertical support in greater detail. Firstly, spacing requirements. As previously mentioned, vertical EMT runs must be supported every 10 feet, or 3 meters. This requirement prevents the EMT from sagging or becoming misaligned over time. Secondly, approved support methods. Use listed pipe straps, U-bolts, or other approved supports that are specifically designed for EMT. Ensure that the supports are properly sized for the diameter of the conduit being installed. Thirdly, secure attachment. Supports must be securely attached to the building structure using appropriate fasteners. Consider the type of wall or ceiling material when selecting fasteners to ensure adequate holding strength. Fourthly, additional supporter transitions. Provide additional support at bends, offsets, and where the EMT transitions to other types of raceways or equipment. These locations are more susceptible to stress and require extra support. Let's transition to horizontal support. Firstly, spacing requirements. Horizontal EMT runs must be supported every 4 feet, or 1.2 meters. This closest spacing is necessary to prevent the EMT from deflecting or becoming damaged due to its own weight or external forces. Secondly, support methods. Use listed pipe straps, J-hooks, or other approved supports that are suitable for horizontal installations. Ensure that the supports are installed in a manner that prevents the EMT from rotating or twisting. Thirdly, uniform distribution. Space supports evenly along the run to ensure a uniform distribution of weight. Avoid concentrating the weight of the EMT on a few supports, as this can lead to excessive stress and potential failure. Fourthly, support at T's and elbows. Provide additional support at T's and elbows to provide extra stability. These fittings are common points of stress and require extra reinforcement to prevent movement or damage. Now let's discuss unsupported spans. Firstly, vertical runs. EMT may be installed without support for up to 36 inches, or 914 millimeters, on vertical runs. This exception is intended to accommodate short offsets or transitions where it is impractical to install a support. Secondly, horizontal runs. EMT may be installed without support for up to 12 inches, or 305 millimeters, on horizontal runs. This exception is similar to the one for vertical runs and is intended to provide flexibility in installation. Thirdly, limitations. Keep in mind that these unsupported spans are intended for short distances only. Avoid exceeding these limits, as this can compromise the mechanical stability of the raceway system. Understanding seismic considerations. Firstly, seismic design requirements. In areas prone to earthquakes, EMT installations must be designed to resist lateral forces. This typically involves using seismic-rated supports and bracing systems. Secondly, seismic-rated supports. Use supports that are specifically designed and tested to withstand seismic forces. These supports are typically more robust and provide greater resistance to movement and vibration. Thirdly, bracing systems. Consider using bracing systems to provide additional lateral support for EMT runs. These systems typically consist of diagonal braces that are attached to the EMT and the building structure. Let's look at inspection considerations. Firstly, pre-inspection checklist. Before the AHA arrives for inspection, conduct a thorough self-inspection to ensure that all requirements have been met. This will help to identify and correct any deficiencies before they are discovered by the inspector. Secondly, documentation. Have all necessary documentation on hand, including product listings, installation instructions, and any relevant calculations. This will help to demonstrate compliance with the NEC and other applicable standards. Thirdly, communication. Communicate with the AHA to understand their specific requirements and expectations. This can help to avoid misunderstandings and ensure a smooth inspection process. Here are some additional installation tips. Firstly, conduit bodies and junction boxes. Use EMT conduit bodies or junction boxes for connections and pull boxes. These fittings provide access to the conductors for pulling, splicing, and maintenance. Secondly, protection from physical damage. Protect EMT from physical damage by installing it behind walls or in conduit. This will help to prevent damage from impacts, abrasion, or other sources. Thirdly, flexible conduit and sleeves. Consider using flexible conduit or sleeves at transitions between EMT and other raceways. This can help to absorb vibration and prevent damage to the EMT. Fourthly, labeling. Label EMT clearly with wire markers or tape. This will help to identify the purpose and contents of the raceway, making it easier to troubleshoot and maintain the system. Following these comprehensive guidelines will help ensure that your 1-inch EMT raceway installations are safe, compliant, and reliable. Remember to consult the latest edition of the NEC and any applicable local codes for specific requirements. This discussion covers additional essential aspects of 1-inch EMT support in building risers for Datacom installations, focusing on practical considerations, advanced techniques, and potential challenges. Let's start with material selection. Firstly, EMT material types. EMT is typically made of steel or aluminum. Steel EMT is more common due to its strength and lower cost, while aluminum EMT is lighter and more corrosion resistant. Secondly, fitting compatibility. Ensure that all fittings are compatible with the type of EMT being used. Mixing different materials can lead to corrosion or other problems. Thirdly, corrosion protection. In corrosive environments, consider using EMT with a corrosion-resistant coating or finish. This will help to extend the life of the Raceway system. Diving deeper into installation techniques. Firstly, cutting and reaming. When cutting EMT, use a proper cutting tool to ensure a clean, square cut. After cutting, ream the inside of the conduit to remove any burrs or sharp edges that could damage conductors. Secondly, bending. EMT can be bent using a conduit bender to create offsets, elbows, and other bends. Follow the manufacturer's instructions for the bending tool being used to ensure accurate and consistent bends. Thirdly, joining. EMT sections are joined together using couplings and connectors. Ensure that the fittings are properly tightened to provide a secure and watertight connection. Fourthly, support spacing. Maintain consistent support spacing throughout the EMT run. Avoid exceeding the maximum allowable spacing, as this can compromise the mechanical stability of the system. Let's explore advanced support methods. Firstly, trapeze supports. Trapeze supports consist of a horizontal bar suspended from the ceiling or other structure. EMT is then attached to the bar using clamps or straps. Secondly, multi-tier supports. Multi-tier supports allow multiple runs of EMT to be supported from a single structure. This can be useful in areas where space is limited. Thirdly, cable tray supports. EMT can be supported from cable trays using appropriate clamps and fittings. This is a common practice in data centers and other facilities where cable trays are used extensively. Potential challenges and solutions. Firstly, limited space. In some situations, space may be limited, making it difficult to install EMT and supports. Consider using compact fittings or alternative support methods to overcome this challenge. Secondly, existing obstructions. Existing obstructions, such as pipes or ductwork, may interfere with the installation of EMT. Carefully plan the EMT route to avoid these obstructions or use offsets to navigate around them. Thirdly, difficult access. In some cases, it may be difficult to access the installation area. Use appropriate tools and equipment to safely and efficiently install the EMT and supports. Considering grounding and bonding in more detail. Firstly, grounding bushings. Use grounding bushings at all EMT terminations to provide a secure connection to the equipment grounding conductor. Secondly, bonding jumpers. Install bonding jumpers around any discontinuities in the EMT run, such as couplings or connectors. This will ensure electrical continuity throughout the Raceway system. Thirdly, isolated grounding. In some sensitive electronic equipment installations, isolated grounding may be required. Follow the NEC requirements for isolated grounding to prevent ground loops and other problems. Addressing fire stopping requirements. Firstly, fire-rated walls and floors. When EMT passes through fire-rated walls or floors, fire-stopping materials must be used to maintain the integrity of the fire barrier. Secondly, approved fire-stopping materials. Use only fire-stopping materials that are approved for use with EMT. Follow the manufacturer's instructions for proper installation. Thirdly, inspection. The AHA will typically inspect fire-stopping installations to ensure compliance with building codes. Here are some safety considerations. Firstly, personal protective equipment. Always wear appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and a hard hat when working with EMT. Secondly, lockout/tagout. Follow lockout/tagout procedures when working on or near energized electrical equipment. Thirdly, ladder safety. Use ladders safely and ensure that they are properly positioned and secured. By addressing these practical considerations, advanced techniques, and potential challenges, you can ensure that your 1-inch EMT installations are of the highest quality and meet all applicable requirements. Remember to always consult the latest edition of the NEC and any applicable local codes for specific requirement. This in-depth discussion aims to provide a comprehensive understanding of 1-inch EMT support in built-in risers for Datacom installations, incorporating practical knowledge and advanced techniques for optimal results. Let's start with understanding the NEC requirements in detail. Firstly, NEC Article 358 Scope. NEC Article 358 covers the use, installation, and construction specifications for EMT and associated fittings. It's essential to understand the entire scope of this article to ensure full compliance. Secondly, support requirements. The code specifies the maximum distances between supports for both vertical and horizontal runs, as previously discussed. It also outlines acceptable methods for securing EMT to structural elements. Thirdly, grounding and bonding. Proper grounding and bonding are crucial for safety. The NEC details how to effectively ground and bond EMT to ensure a safe electrical path. Fourthly, ampacity considerations. Although primarily focused on support, remember to consider conductor ampacity within the EMT. Overfilling the conduit can lead to overheating and potential fire hazards, so refer to the appropriate NEC tables. Let's dive into advanced installation practices. Firstly, using strut systems. Strut systems, like Unistrut, offer versatile solutions for supporting EMT runs, especially in complex or crowded spaces. Strut can be mounted to walls, ceilings, or floors, providing a solid framework for attaching EMT. Secondly, prefabrication. Prefabricating EMT runs off-site can save time and improve accuracy. This involves cutting, bending, and assembling sections of EMT in a controlled environment before bringing them to the installation location. Thirdly, using specialized tools. Specialized tools such as hydraulic benders and threaders can make EMT installation easier and more efficient. Invest in quality tools to ensure precise and professional results. Fourthly, color coding. Consider color coding EMT runs to identify different circuits or systems. This can simplify troubleshooting and maintenance in the future. Expanding on seismic bracing techniques. Firstly, identifying seismic zones. Determine the seismic zone for the installation location. This information is used to determine the appropriate level of seismic bracing required. Secondly, using seismic rated hardware. Use only hardware that is specifically rated for seismic applications. This includes supports, clamps, and bracing components. Thirdly, bracing patterns. Various bracing patterns can be used to provide lateral support for EMT runs. Consult with a qualified engineer or seismic bracing specialist to determine the best pattern for your specific application. Fourthly, documentation. Maintain detailed documentation of all seismic bracing installations, including product specifications, installation instructions, and inspection reports. Discussing best practices for cable management inside EMT. Firstly, minimizing bends. Minimize the number of bends in the EMT run to reduce pulling friction. Use large radius bends whenever possible. Secondly, using pulling lubricant. Apply a listed pulling lubricant to the conductors before pulling them through the EMT. This will help to reduce friction and prevent damage to the insulation. Thirdly, avoiding overfilling. Avoid overfilling the EMT with conductors. Refer to the NEC fill tables to determine the maximum number of conductors allowed in a given size of EMT. Fourthly, securing conductors. Secure the conductors inside the EMT using cable ties or other approved methods. This will prevent the conductors from moving or becoming damaged. Considering how to address common installation challenges. Firstly, navigating tight spaces. Use flexible EMT or short radius elbows to navigate tight spaces. Alternatively, consider rerouting the EMT run to avoid the obstruction. Secondly, working at heights. Use appropriate fall protection equipment when working at heights. This includes harnesses, lanyards, and lifelines. Thirdly, dealing with corrosion. In corrosive environments, use corrosion-resistant EMT in fittings. Alternatively, apply protective coating to the EMT to prevent corrosion. Fourthly, maintaining proper grounding. Ensure that all EMT connections are clean and tight to maintain proper grounding. Use antioxidant compounds to prevent corrosion at the connections. Reviewing inspection and compliance tips. Firstly, understanding local codes. In addition to the NEC, be sure to comply with all applicable local codes and regulations. These codes may have additional requirements for EMT installations. Secondly, scheduling inspections. Schedule inspections with the AHA at the appropriate stages of the installation process. This will help to ensure that any issues are identified and corrected early on. Thirdly, maintaining documentation. Maintain detailed documentation of all aspects of the EMT installation, including product specifications, installation drawings, and inspection reports. This documentation will be helpful in the event of future inspections or maintenance. Fourthly, training and certification. Consider obtaining training and certification in EMT installation. This will demonstrate your competence and knowledge of industry best practices. By incorporating these advanced practices, you can achieve superior results in your 1-inch EMT installations. Remember to always prioritize safety, compliance, and quality workmanship. This extended narration offers a highly detailed and comprehensive guide to supporting 1-inch EMT in building risers for Datacom installations, covering a wide range of topics from NEC requirements to advanced techniques and best practices.